was the one you didn't do? Which one?
We did like 1, 3, 5. He just skipped around.
Oh, he did. Okay. Can you show me which ones you did do? That way
He did them all. Yeah.
Oh yeah, but I mean like he just.
Oh, you mean he didn't necessarily answer all the individual parts?
No.
So, like for example, for number 1,
Yeah.
he did number 2, but with the numbers for number 1.
Correct. That's what I wanted.
Oh,
yeah.
okay.
Yeah, yeah, absolutely. Because that way you don't have to start all over again. You can just do the same problem. That's correct. That's what I wanted him to do. And in fact, if you downloaded the answer key from online, the PDF, I scratched those out as well.
So we should have the same numbers.
Yep, so it's the same equations on top and bottom. Yeah, yeah. So is that what you meant?
Yeah.
I'm sorry that wasn't clear. Yeah, my goal was to have the same equations. That way, at the top, you're finding the consumer surplus, and at the bottom, you're finding the producer surplus. But you don't have to do the work of finding the point of intersection every single time. Okay, so therefore, you did do 1 and 2, 3 and 4, 5 and 6. And correct?
Yeah.
And then did you do 7 and 8? And 9? Okay, so you did all of them. Okay, yeah, except for 10. Okay, well, great. Then, is there one in particular you'd like to review from the 1, 2, 3, 4, 5, 6 problems? Because I wouldn't mind doing at least one of them. A formula sheet for the test. Yeah, we can work one up together today. Yeah, while we review for the test. So yeah, is there one from 1, 2, 3, 4, 5, 6 that you would like to see? Yeah, which one?
You read number 7.
Oh, okay. So nothing from 1, 2, 3, 4, 5, 6. Then let's just talk about 1, 2, 3, 4, 5, 6. The idea was that if you have a supply curve and a demand curve. Now, which is which? Which is this one? Yeah, this is the demand curve. Now, you might know that because you just look over here and it says demand curve. But how do you know which one is demand and which one is supply? And keeping in mind that this is quantity. So this is the quantity of how many would either be consumed by the consumer or supplied by the supplier. As the number of quantities that the consumer is willing to buy increases, what must be happening to the price? Like if more and more people are willing to buy your product, what must be happening to the price? The price is going down. So that way we know for sure that this is the demand curve. That makes sense. That as the cost, this is the price, as the cost of the item goes down, consumers will want to consume more and more of the product. Whereas for supply, if the supplier is willing to supply more and more of your quantity, that must mean that they're getting to charge a higher price, and so it's worth it to them to supply more. Okay, and so what's this point called right here? Yeah, the equilibrium point. That's the equilibrium point where consumption and production are balanced. So this is a very happy point right here. It means that right there at that point, you have, for a given quantity, the number consumed and the number supplied are identical to each other. So that's a good number to shoot for in an economy. That means that, for instance, you wouldn't want to be over here because then the amount, you wouldn't want to be, this is price. You wouldn't want to set the price too low because then you'd have less production and more consumption. And so the businesses would run out of stock and you'd have a whole bunch of consumers who didn't get to buy it because the store went out of stock. And you wouldn't want to set the price too high because then you'd have less consumers than you have suppliers. And so there'd be way too much supply, and so a bunch of products would be sitting on shelves or sitting in warehouses not being purchased. Whereas you would want to set the price right here because then the number of products that were supplied is equal to the number of products that were consumed. And so everybody gets a product and there's not a bunch of overstock left in the garage. Everybody's happy. So that's the equilibrium point. What are these shaded areas representing? Like what is this shaded region up top? Yeah, that's the consumer surplus. So does this region make sense as to what we're talking about? What does consumer surplus mean? I think I wrote it on my notes that I posted as a PDF online. But what does that mean? The consumer surplus. Let's just take a look at a particular point right here. Here you have, and keep in mind, the whole point of consumer surplus and producer surplus is that you did choose the equilibrium cost. So in the economy, How much are we charging for this particular good? We're charging the price determined by the equilibrium. So if we do charge the cost determined by equilibrium, let's just say that that cost is 20 bucks. Let's say that up here at the $30 region, you had some consumers who were willing to spend $30. How many? Well, this many, however many Q that would represent. But you had some number of consumers who were willing to have spent $30, but they only had to spend 20. So what does that mean for me? I'm a consumer, I would have spent 30, but I only had to pay 20. How do I feel? I would have spent 30, but I only had to pay 20. How do I feel? I feel good. I'm happy. And in fact, how much happiness do I feel in my wallet? $10 worth of happiness. Because that's $10 I would have been willing to spend, but I didn't have to. And that's what consumer surplus is. This whole region right here, if you calculate this area, it represents a total dollar value of the amount of money that these consumers would have been willing to spend to buy that product, but they didn't have to, because the product price was lower than what they were willing to pay. So you add all that up, and it turns out to be thousands of dollars in money that consumers would have spent, but they didn't have to. So consumer surplus means all of us consumers still have that money in our pockets, and we can go to McDonald's and buy a burger, or whatever. So that's consumer surplus. It's a positive thing for the consumer that I still have money left in my pocket that I would have spent. So what is producer surplus?
Charging more, higher price, so more you need.
Let's check. Say that again.
They're charging a higher price for the item. So
They are charging a higher price for an item?
the more they pay for the item. Consumers.
Is it profit?
Profit, yeah. Higher profit.
Yeah, potentially, yeah, it's extra profit. What are you saying, Lance?
Yeah, is it profit?
It could be extra profit. We don't really know if it's profit yet because we don't know about costs. Remember, profit is equal to revenue minus cost. So we don't know anything about profit. We just know about revenue. This will just be revenue, which is price times quantity. So their revenue, let's just take an example. Let's say, again, here's our equilibrium cost. So this is how much they actually charged. But the supplier, right here, the supplier was willing to charge less. They would have charged less for that product, but they actually got to charge more, and they actually got people to buy it. So the supplier would have been willing to sell it for less, but they actually got more money. So that's like extra money the producer got. I would have been willing to sell my lemonade for only $1 a cup, but everybody was buying it for $5 a cup. So I made $4 a cup more than I expected. And that's what producer surplus is. There, if you look at the supply curve way down here, this is price again. So right here, they would have charged less per item than the price they actually got to charge at the equilibrium price. And so because they got to charge the equilibrium price, which was higher than what their own supply curve determined, they actually got to charge more than what they would have been willing to charge. And that meant extra money in their pocket. So that's amazing. That means that the producers also made more money than they were hoping to make. So again, just imagine if I had a lemonade stand and all I really wanted to do was charge $2 a cup, but everybody in the economy was willing to spend $5 a cup. I'm getting $3 extra for every cup of lemonade out of just sheer dumb luck, because that's what the equilibrium quantity was. So producer surplus is extra money in the producer's pockets that they earned, even though they would have been willing to earn less. And so you put both of those together, consumer surplus and producer surplus, and what did they call that? Total gains from trade. I think that this right here is some sort of like big advertisement for capitalism, right? Like, hey, look how great capitalism is. Because in capitalism, if you allow the market to determine the equilibrium quantity through supply and demand, you get this consumer surplus and producer surplus, which is a total gains from trade, and that's why we should use capitalism. Okay, well that's what those things represent. So if nobody has questions on 1 through 6, then we'll keep going. So which word problem did you want to see? 7, 8, or 9? 7? Okay, let's look at 7, which is great because that's like this problem. It says here, suppose the demand function for a product is given by that. So, of course, what are we going to start by doing? Drawing a picture. This is just a linear function with a y-intercept of 56.1 and a slope which is negative. So I'm just going to draw a basic graph with a negative slope. So there we go. That is our demand function. And they're asking us to find the consumer surplus corresponding to 800 units. So I'm going to come right here and put 800 units. I'm going to mark that point. And I want to find the consumer surplus. Now, what's weird about this problem? What is it missing? What is this problem missing that 1, 2, 3, 4, 5, 6 had? Yeah, there's no equilibrium point because what didn't they give us? Every other problem gave us a supply and a demand function. We were only given a demand function. Where's the supply function? They didn't give it to us. Now, keep in mind, in all the previous problems, you had a demand curve, you had a supply curve, and then we looked at this area right here. This was consumer surplus, and this was producer surplus. And we had an equilibrium quantity right here, which went to a certain value of quantity. So when they ask us to solve for consumer surplus, what area do we want to find? Now this area right up here. Did they give us a supply curve? We don't have a supply curve. But they're asking us to find the consumer surplus relative to this quantity, which is right here, which goes with that one right here. So geometrically, what area am I looking for? What do I need to shade on my picture to make it look like that picture? Yeah, that part right there. That will represent the consumer surplus because geometrically it's the exact same area that we're looking for. And in fact, does the supply curve even matter? When you're trying to find this top triangle right here, does this supply curve matter at all? It doesn't matter at all. So all we really need to do is determine some fixed quantity. They told us 800, and then to find the upper triangle right there. Okay, well, we could do this in one of two ways. You could do it geometrically, and sometimes I like to do a problem geometrically just so I immediately know what the answer is. So let's try that. We can just calculate the area of that triangle. Do I know how wide the triangle is? 800? Do I know how tall the triangle is? No, I don't, but I do have a function which tells me this y value. So what do I have to do? Plug 800 into that. So negative 0.017 times 800 plus 56.1. That's 42.5 right there. Now do I know how tall the triangle is? Yeah, 56.1 minus 2.5. So the height is actually 13.6. So what I have here is a triangle whose height is 13.6 and width is 800. And therefore the area of a triangle is 1/2 base times height, which is 0.5 times 13.6 times 800, which is 5440. Is that the consumer surplus from the packet? Okay, goody. So geometrically, that's what we're looking for. We're looking for the area underneath the demand curve, but above the equilibrium cost. And by the way, that's the equilibrium cost, 42.5. So we're kind of saying, pretend that 800 quantity and 42.5 cost is the equilibrium point. And if you do pretend that that's the equilibrium point, what's the consumer surplus right there? Which is just the area of the triangle. Now, by the way, I'm going to go ahead and label this coordinate. That's the coordinate 800, 42.5. Okay. Now, if you use that technique on the test, will I give you full credit? No, because this is just a geometric interpretation of just finding the area of a triangle. I'd like to see the calculus. So what's the formula for consumer surplus? It's the integral from 0 to what?
Yeah.
Yeah, to the equilibrium quantity, which is 800, of the demand curve, which I know the demand curve is negative 0.017Q plus 56.1. So dQ. And then after that integral, what do you do?
Subtract it by
The product of the equilibrium point, the equilibrium coordinate. So we're going to do the product of 800 times 42.5. Is that correct?
Yeah.
Yeah. So there we go. That's our consumer surplus formula. If I wanted to write that out in general formula, it'd be 0 to the x equilibrium point times the demand curve, and then minus the equilibrium point times the equilibrium cost. There. Was that the formula that you all wrote down? Yeah. Okay. So at this point, it's just a matter of doing that integral. So what's the antiderivative of negative 0.017Q? The anti-power rule? What's the anti-power rule for negative 0.017Q to the first? Yeah, add 1 and then divide by 2. So that gives us negative 0.017 over 2Q squared. And what's the antiderivative of the number, 56.1? It's the number with the variable. Yeah, 56.1Q. So we have 56.1Q. We have all that now being evaluated from 0 to 800. And then we subtract the 800 times 42.5, which is 3,400. Or no, 34,000. There we go. So now this integral, I can type into my calculator. What's so nice about having a lower limit of 0?
it's always
It's just 0. Well, almost always, provided it's polynomial, yeah. If it's e to the, you actually still have to calculate it because e to the 0 is 1. But as a polynomial, yeah, that one's just 0. So now I just plug 800 into both of those. And so that's a job for my calculator. Negative 0.017 divided by 2 times 800 squared. That's negative 5440. Plus 56.1 times 800, that's 4480. Minus 34,000. And so theoretically, anyway, it's negative 5440 plus 4480 minus 34. And oh my goodness, I get 5440. So the calculus method agrees with the area method, which makes sense because the whole purpose of the calculus integral, the integral is to find the area of shapes. Theoretically, of curvy shapes, this is not a curvy shape. And since it's not a curvy shape, we can apply basic geometry to get the same answer. But had our demand curve been a parabola or some curvy shape, we would have had to use this technique rather than a geometry technique. But it's nice to have two methods to solve the same problem. Because that way, on test day, you can do the problem this way, and then you get to here, you're like, geez, did I get the right answer? And you can check by just doing it geometrically. And that way you can check your own answer.
So
Okay.
how'd you get the divide by 2 part? It's not-
The anti-power
okay.
rule. So remember, if you have, say, just 3x to the first, what's the anti-power rule say? Yeah, plus 1, and then divide by the 2. Yeah. Karina?
How'd you get the 42.5?
Because remember, when we talked about functions, f of x is always equal to the y coordinate, and f prime of x is always equal to the slope, and f double prime is always equal to the concavity. So that's just a general statement. So if I want to know, this is 800, how high is it? Which one of those tells me the height of a curve? Yeah, just the regular function. And so our regular function was d of q. And so I just plugged 800 into that. Go ahead and plug 800 into that function on your calculator and check to make sure that you get 4250. Because that's what I did. Okay, now you guys did that problem with Williams, right? Okay, but it was nice to see it again. Wendy, you asked for that, right? Does it make more sense?
Yeah.
Okay, good. All right. Folks, have you ever felt consumer surplus in your life? I mean, what does consumer surplus feel like? Like if you were going to describe it to someone who's never taken an economics class or a math class, you'd say, oh yeah, consumer surplus is just any time you
It's like deals on.
get a deal. Exactly right. It's anytime you get a deal.
Discounts.
Yeah, you get a discount, you have a coupon, yeah, you talk to the manager, you get the price brought down, anything like that. I had an experience like that just this morning as I was driving into work. My daughter has this Contigo bottle, like a little Contigo water bottle. My daughter's 20 months, but she drinks out of this thing. And the straw on the inside disconnects all the time. So she goes to drink from it, but no water comes out. It's very inconvenient. So I called them up and I said, this water bottle is terrible. And they offered to send me a brand new one of a different type. So, woohoo! Like, now I get a free water bottle in the mail. They're just going to send it to me. And I feel consumer surplus now because I didn't have to go return the other bottle. I didn't have to pay for the new bottle. I feel like everything's worked out in my favor. Now, is that really consumer surplus? I don't know. Maybe that's just a good day. I don't know. Yeah, but consumer surplus is a good deal. What does producer surplus feel like? Imagine you're owning a business right now. What does producer surplus feel like? This is going to sound bad. Maybe a scam? That's funny. You'd be like, I totally charged them more than I wanted to. That was awesome. I only wanted to charge 10 bucks. I charged 20. Right? So producer surplus, that sounds kind of mean. Like you're taking advantage of customers. But it's not mean. It's just you got to charge more than you were willing to part with the item.
Like Craigslist.
Yeah, Craigslist and stuff. I was willing to sell it for 10 bucks, but I got to charge 20. It's my lucky day. Who's going to raise their hand? Anna? No? Somebody had their hand up. No? Okay. All right. Well, that's it for that particular question. How about 8 or 9?
You do number 9.
Yeah. Now, I think 8 and 9 were both the same. Yeah, they were. Yeah, 8 and 9 are all similar in terms of the setup. So let's just remind ourselves what the setup is. The setup is that formula that I have on the screen right now. Present value of an income stream is given by, so let me copy that down. Present value from 0 to the time period of your particular function, right? Times e to the negative RT. Now that's the surprising part, is that there's an e to the negative RT in there. So this part is the income stream. So in this case, let's read the problem. A company is considering expanding their production capabilities of a new machine that costs $39,000 and has a projected lifespan of 8 years. They estimate the increased production will provide a constant $5,000 per year of additional income. Now what I mean is a constant $5,000 per year of additional income. I'm going to go ahead and put in 0 to 8 because we're doing it for 8 years. And for the F of T, my income stream, I'm going to put in $5,000 because it's $5,000 per year that I'm getting in income stream. And it's constant because essentially it's like a tap of water on your bathtub, and then turn the water on, and the water is going to fill the bathtub such that at the beginning you're at $0, and at the end of the year, your bathtub is filled with $5,000. But I'm representing as water, a continuous flow of money. So I don't know if you ever watched DuckTales or anything like that, but just imagine turning on your bathroom faucet and coins fall out, and a continuous stream of coins into your bathtub. And by the end of the year, there's $5,000 in coins. But the coins are just constantly flowing out. Okay, so money can earn 1.6% per year compounded continuously. That's the second part, is that if you've got that $5,000 and the money is going into your bank account, what you really are doing is you're putting that money, you're asking, what if I had invested that money and it's also earning interest? So now that's the second part, e to the negative, what was our interest rate? 1.6%, so 0.016 dt. So we're saying yeah, they estimate the increase in production is $5,000 per year of additional income, and money can earn 1.6% per year compounded continuously, should the company buy the machine. So I'd like you to consider this alternative, okay? What they're really doing is wondering, how can we make more money? So plan A is spend $39,000 to buy a machine that makes $5,000 per year. Now, at face value, how much money are we going to get? We do that for 8 years. Yeah, so I mean, $5,000 per year times 8 years, that's $40,000. So spending $39,000 to make $40,000, is that a good deal? I mean, how much money did you make? $1,000. So I mean, that's a long-term investment, isn't it? You got to wait 8 years to make $1,000. How much is that per year? I mean, take $1,000 divided by 8. That's only $125 a year. $125 a year. How much is that per month? $10 a month. I can go out on the street and ask for money and make more than $10 a month, right? So I mean, is that really an exciting investment opportunity? I don't know. So what's plan B? Invest my $39,000 at 1.6%. So that's truly the alternatives that we're considering. I can either put my money into a machine and then use that for the next 8 years to make that $5,000 per year, or I can just sit on the $39,000, not do a darn thing with it, just put it in the bank and make 1.6% interest. So how much money is that? If you use continuous compounding, A equals P to the RT, so hold on, this was worth $40,000. So on the other hand, if I do PE to the RT, that's 39,000 E to the 0.016 interest rate for 8 years. How much money is that? So that's E to the 0.016 times 8. And then I'm doing that times 39,000. That made me $44,000. So at face value, which is better? I mean, probably plan B. Don't bother buying the machine, just invest your money, you'll make more. Isn't that weird that it could be possible that the better way to make money is not to do anything? Don't open a business, don't run a business, just invest the money you already have and just make interest on it. Okay, so those are what you're considering. This, though, is going to tell you the present value of that income stream, the present value of what it's worth in the present. So let's do the calculation. How do you do the antiderivative of e to the nt? This is one of our formulas. The antiderivative of e to the nt. What's the integral of e to the nt? What's the integral of e to the nt? The antiderivative.
E to the nt.
It's still going to be e to the nt, but there's something in front. Y'all have it written down on the formula sheet somewhere? The integral of e to the nt?
Oh, 1 over n.
Yeah, 1 over n e to the nt. 1 over n e to the nt. So that's the integral of e to the nt. So you do 1 over n e to the nt. So now let's go ahead and do this one. My integral, therefore, would be 5,000 divided by negative 0.016 e to the negative 0.016 t. And we're going to integrate that from, or evaluate it from 0 to 8. So there's the integral. Now you guys already did this one, right? Okay, so we're just reviewing. So now what is that? Let's compute that. So 5,000 divided by negative 0.016. So that worked out nicely of 312,500. And then that's e to the 0.016 t evaluated from 0 to 8. So now here, the 0 is a lower limit we can't just ignore. Because when I plug 0 into that, that's actually e to the 0, which is e to the 1. I'm sorry, e to the 0 is 1. So we have to do both. So it's going to be 312,500 times e to the 0.016 times 8, e to the 0.128, minus 312,500 times e to the 0. That's my fundamental theorem of calculus right there, the parenthesis minus the parenthesis. So now you have to evaluate both of those. 312,500 e to the, oh, sorry, that's a negative, isn't it? Those are all negatives.
Isn't the exponent a negative 2?
Yes, thank you. My goodness. Well, not that one. Yes, those are all negative. So, negative 312,500 e to the negative 0.128 is this. And then that's a double negative, so that's plus 312,500. And I got a total difference of 37,545.8. Now what is that? That's the present value of the income stream. So let's go back and see what it said here. It said, should the company buy the machine? So the present value of the machine. So they're asking, you've got this machine that can generate $5,000 per year, and it'll make that money. But as you make that money, you know, you're only getting $5,000 this year, so that's the amount you can invest to make interest on this year. And then you'll get $5,000 next year, so then that $5,000 you can invest and make money on. And so then by the end of the 8 years, that last $5,000 that you make, you don't get to invest and make money on at all. So if you think about all that future money that you're going to get, which is the $40,000, how much would you need to have today to invest that would make back up to the $40,000? And that's what they're saying. This is the present value of a machine that will make you $40,000 in the long run. And so instead of making the $40,000 in the long run, how much money would I need to have today to simply invest to make $40,000 through interest alone? And that way I can just ignore buying the machine and not bother. So let me say that again. We just found the present value. This is the present value of the income stream of $5,000 per year. So we're essentially asking, I could buy this machine and get $5,000 per year and end up with $40,000 at the end of it. Or if I simply had $37,545.80 today, I can invest it and get $40,000 at the end of 8 years. So looking at those choices, the fact is we have $39,000. We already do have $39,000. So that means I have more than enough money to simply invest this much money to make the same amount of money as the machine. And then I can save myself 8 years of heartache of buying a machine, maintaining it, using it, manufacturing things. So the fact is that because the present value is less than the purchase price, we should not buy the machine. So hold on a second. Yes, the present value of the machine is greater than the cost. No, the present value is less than the cost. The cost is going to be $39,000. So no, the present value of the machine is less than the cost. By how much? What's $39,000 minus $37,000? Is it $1,454.19?
Yeah.
Okay. So the answer is no. Right? Is that what you guys said? The answer was no? Okay. I suppose the real question is it clear what present value means? This is how much money you'd have to invest today to get a total of $40,000 through interest alone. So if I could invest $37,000 today, then through interest alone, I'll get $40,000. Which means I don't have to bother buying a machine and dealing with having a machine for 8 years.
That would be over 8 years.
What?
That would be over 8 years.
Yeah. If I put 8 years of interest on top of this, I'll get $40,000, which is the same amount of money I get if I buy a machine. And again, nobody wants to buy a machine if you don't have to, because the machine could break. Mice could eat your machine. Something could happen to it. You could have a rainstorm. Now the machine's broken. Like, there's all sorts of problems with buying a machine. So if instead of buying a machine and doing manufacturing, you can just invest some money and get the same amount of money, you definitely want to just invest the money. So by finding the present value of that income stream, now we know that I shouldn't buy that machine for $39,000. Because I can invest less than $39,000 and make the same amount of money that the machine is going to give. Okay, well, folks, number 10, I told you to skip, right? Yeah, so number 9 and 8 are the same. It's the same exact interval. Yes, it is. Okay, so how about, let's do this. Let's transition and have everybody write down what questions they'd like to go over. So you can just take a moment and look through your packet. And how many questions are there? 44? There's 44. So, did I already post the answer key to the practice test? Well, I didn't. I have an answer key to the practice test. I'll post that for you. At least, gosh, I hope I have an answer key to the practice test. I feel like I do.
You did?
Wait, I did?
Yeah.
Oh, thanks, Luis. I thought I did. I really thought I did. So yeah, I did post the answer key to the practice test. So the whole darn practice test is online. In fact, I said that to you last class session. Before we left last Thursday, I told you I posted it online. Yeah. So it's online. By the way, this is a grade. I'm collecting it on Tuesday. So I really made that one easy for you. You found it, Daniel?
Yes.
Okay, good. Yeah, it's in the announcements, right? Yeah. So we're gonna do, I'll smooth this up real quick. Oh, no, I can't do that. I'll do it over here. I'm gonna write up the numbers 1 through 44. And everybody gets to vote on, what did I say? Choose 5 problems. Yeah, choose 5 problems. Just put a little chicken scratch. And then we'll go in order of most voted problems. So whatever problems you all vote on the most, those are the ones that we'll review, and we'll try to cover as many as we can. Okay. Come on up, folks. And let's use the colored markers. Everybody has to vote on 5 problems. Obviously, you might need to take a couple minutes to look at that real quick. So let's see here. Let's build this into not a 15-minute break, but I'm giving you a couple minutes to choose what problems you want. So it's 11:41. Let's say that we all are back in our seats ready to go at 11:55. So by 11:55, please come up, choose 5 problems, and take a break.
So it's like our break and like the.
Yeah, I'm giving you 4 minutes to choose some problems, and I'm giving you a break.
Okay, cool.
Just as an example, I'll also choose some problems that I think would be good to review.
How big is this test gonna be?
It's normally going to be 4 pages front and back, and I think it's probably like 20 to 30 questions. Thank you. Then have you memorized which ones?
Yeah.
Wow.
You have a test. Mr. G?
Yeah.
Oh, is it? Oh, okay. Oh,
Tuesday we have.
I don't know. Okay, never mind. I was just wondering when their final was.
Oh,
Is it the still the same time as class time, or does it like change like the other classes?
I believe so.
Okay,
Anna, did you get my math AS responses?
I haven't checked right now.
Oh, okay. It seems to me like
Because I don't know. I look over the videos and they get, but when I plug things in, I don't know if I'm really like off of when I plug things in, but I don't get it.
now one of them it looked like your variable choice. They used the variable X and you typed it in with R, so that could have been one.
Oh, because I used the formula.
Yeah.
That's why.
So you might want to make sure the variable is the same variable.
But then there was one that I had. If I remember right, it was Z and X.
Yeah,
And it
what-
kept saying me about the variable also, but then I kept checking everything and I kept getting, I thought that was getting the right answer.
if you have time, we can do it right after class.
Yeah, because I don't know, I feel like I'm getting points taken off because, well, I don't know if I'm like maybe off in my answers or maybe I'm really off in how I'm plugging it in.
Right, it's one or the other. But we'll check and we'll figure it out. Oh, isn't today the teacher walkout?
Yeah.
Yeah.
Yeah, at high schools. Yeah. Wow, interesting.
I have a question. I remember right. But there was something that you turned into to get it.
Yeah, you get 30%. If you just let me know, I'll open it back up.
Yeah, I was wondering.
Theoretically, you have late passes. If you click late
Yeah,
pass,
okay, what happened was that when I was in Hawaii, I went crazy with the late passes because I was like, I'm not gonna do it. And then you extended it to, so in a way, I kind of like wasted all my late
well, I
passes.
can give you more. It's fine.
Oh, okay. Thank
Yeah,
you.
just tell me what sections you need.
I'm trying to three.
Will you email me?
Oh, yeah.
Yeah.
Oh, yes, what happened was that we wasn't different. I was like, I'm prepared. So I used my late passes there to give him more time for that. And then he moved these around, and then I'm like, oh, I just wasted them. Mr. G,
Yep.
with this test, is it gonna be almost like the other one, like a big practice and it's gonna be small?
Yeah,
for them?
sure.
You know, it's a good idea. You know, I have a good knowledge for this. So then you don't have to everything happen. It's just like writing the content when you stop.
See, I don't.
Next thing is, oh, we just doing exams.
Because I took things out last time.
But then you just like go I don't know because of how she lost.
Do you have any questions?
Yeah, because I feel like I'm like,
I'm not lost. She's sensitive. The horizontal vertical, I got that. And then you do that.
And then
Use-
today, yes, so it's like,
Oh,
well, except for the, what we did today, the college class, into the balance sheet or.
so it will be
I'm gonna email her if she can do the same thing for the benefits, so I know that she wouldn't know what the same thing. Yeah.
So you just copy paste.
That pretty much is like, she was
One
but we're not doing anything.
sent to.
That guy asked her. And then we took
It's Tuesday. And that's the one we only have to get the just outline.
Okay, folks, let's go ahead and get started. Did everyone get a chance to come up and choose some? Let's see, I think I saw Marina and Elias, you came up?
Yeah.
Mario, you came up? Okay, Luis, you did too? Okay, all right, so let's take a look here. I'm gonna start with the ones with the most votes, so 17 and 28, 25, definitely 34. This one has 4, and then we've got a couple with 3. Well, let's make our way through those first. So we're doing a triage. Do you guys ever use the word triage? What is triage? I think triage is a nursing medical term in the emergency room. What does it mean to triage? Anyone know? Maybe you've watched Grey's Anatomy or ER or any other TV show about emergency rooms. Triage means to look for the patients that are worse off first. Like if you have 2 people that came in, one person stubbed his toe and the other person has half his neck cut off. Like you would triage and help the person with the neck issue first before helping the person with the stubbed toe. So let's talk about these biggest problems here. All right, so number 17. Oh, goody. Oh, great. So 17, we want to take the indefinite integral of 3x to the 4th plus 6 over x plus 3 over x to the 6th plus 5 root x. All right, and so we actually have a couple different rules up here. Like that's a particular rule, that's a slightly different rule, that's a slightly different rule, slightly different rule. So first of all, how do we have to rewrite all these things? Specifically, this one's fine. But how do we have to rewrite this one? Well, if you did push x to the numerator, it'd be 6x to the negative 1. But this was actually a trick question.
When you pull it out,
This-
it's natural. 1 over x.
This is really 1 over x, and the integral of that's going to be natural log. So that one can stay the way it is. We can write that as 6 times 1 over x if you like, just to remember to see the 1 over x. This one, you have to bring the x to the numerator as 3x to the negative 6. And what about that last one? Root x is actually, x to the 1 half. So each of those, we're going to take the integral of using power rule, natural log rule, power rule, power rule. So we have 3 power rules up here and 1 natural log rule. So what's the antiderivative of 3x to the 4th? Add 1 and divide by the result. All right, add 1 to the power, divide by what you get. Okay, so how about the next one? The antiderivative of 1 over x is natural log of x. Yeah, ln. Okay, and then again, the anti-power rule, add 1, and then divide by the result. So negative 6 plus 1 is negative 5, divide by the result. And then the last one, add 1. Now instead of adding 1, what should we add? 2 over 2, just to make it easier. So that gives us x to the 3 halves. And then divide by the result. I'm going to do some scratch work. 5 divided by 3 halves is really 5 divided by 3x, which is really 5 times 2/3, right? Because dividing by a fraction is the same as multiplying by the reciprocal. So that's really 10/3. So I'm going to go ahead and just write 10/3. But keep in mind, I did a lot of scratch work somewhere else to walk me through that. I don't expect any of you to do that in your head. If I did that in my head, I might get in an accident. No, we don't want to risk that. So just do some scratch work somewhere, find out what 5 divided by 3/2 is. Okay, so that's it. That's our integral. So now we just clean it up, right? So this is 3/5 x to the 5th. That's 6 natural log x. This is just minus. Ooh, how do I clean this up? The 3 is in the numerator. The 5 is in the denominator. Where does the x to the negative 5th go? That back into the denominator, 5x to the 5th. So that's minus 3 over 5x to the 5th. And then the last one, you can just leave like that. 10/3 x to the 3x.
In the second one, it's actually minus the second 3x.
Oh, it is. That's minus there. That's a minus there. Thank you, Wendy. And that's a minus there, so it's a plus. Thanks, Wendy. Okay. So there's that one. Now, to be honest, like already, it probably would be helpful if we already had our list of formulas. So we need to make a formula list. But here's the thing. I'm not going to have you guys make a reference sheet. I think I'll make a reference sheet. But what do you think? Should it be that I ask each of you to make your own reference sheet? I don't think so, because then everybody's putting something slightly different. I'd much rather us all have the same reference sheet. So I'll just bring one to class. So you guys will have a reference sheet on the daily test. Okay, so that was that one. Questions about that? Theoretically, we'd have to put a plus c at the end there, because this was an indefinite integral. We weren't calculating an area, we were just calculating the antiderivative.
Let's see it at the test.
I would put it on the test, yeah. Anytime you do an indefinite integral. Because remember, how do we even know that this is correct? What would you do? You take the derivative and make sure you get this back. And what happens when you take the derivative of a number? It's equal to 0. And so it goes away. And that's why the c is necessary, because you're not sure what the c value is. Okay, next, 23. There we go. Okay, 23. It says evaluate the integral by making the u substitution. So that's very kind of them. They actually told us what u substitution to make, but did we need them to tell us that? No. We could have figured that out on our own. So we want to do a u substitution. And remember, to do u substitution, you're looking for the inside expression. So what's the inside expression there? Yeah, x cubed minus 10. We know that that's the correct choice for u, because once you're done choosing your u, and you take the derivative, so now du equals 3x squared dx, the derivative of u should give you something that matches the other part. So we accounted now for the x cubed minus 10. We also needed to account for an x squared, and the derivative of u gave us an x squared. So that's actually what made u the correct choice. Is that when you choose the correct expression for u, you get another piece that you have elsewhere in the integral that needs to be substituted. Okay, so now what do I do with that 3? I move it over, so it's really 1/3 du is going to replace x squared dx. So now I have something to replace my x cubed minus 10, my x squared, and my dx, and they all get replaced. So what do I write down? Instead of x squared and dx, I write down 1/3 and du. And instead of x cubed minus 10, I just write down u within 36. So that's u substitution. It takes an integral that we don't technically have a formula for. We don't have a formula that matches that. But by doing u substitution, I can now pull the 1/3 outside, and this is just the power rule. Very simple. just the power rule. And I do have a formula for the anti-power rule. So what do I do for the anti-power rule?
Add one.
Yeah, add 1 and then divide by the result. So 37 divided by the result. I also have my 1/3 out front. So that gives us what? Is it 111? Do the 37? Yeah. And then technically that's 1/111 u to the 37 plus c. Well, what's the last thing we have to do? Yeah, plug it back in for what our u choice was. Our u choice was x cubed minus 10. And how do we know if that's correct? You take the derivative. And so the derivative is technically the chain rule. You bring down the 37 first, leaving the inside alone, and then multiply by the derivative of the inside. And what's the derivative of the inside? Just 3x squared? Here, let's do it just to make sure. If I take the derivative of this, then that would be 37, leave the inside alone, to the 36th, then multiply by the derivative of the inside, which is 3x squared. And so I can also bring the 3 over here. 3 times 37 is 111, so that cancels out completely. And I'm left with x squared being multiplied by x cubed minus 10 to the 36th. So it did work out. So that's u substitution. Extra questions you'd like to ask about u substitution? Anna?
Yes, just making sure because the key you gave us less steps. Do you want this steps or less the other steps like how you did on the key?
What step did I leave out?
Well, I mean, not like steps, but we showed extra work here.
Oh, is this it?
Yeah.
Oh, yeah, so there's my u substitution. I put it right in, I did that, and then, oh, I don't know what extra steps I did. Oh, well,
I
like,
mean like extra work.
yeah, I just showed how I multiplied that times that.
Do you want
I'm fine with what that is.
Okay.
Yeah. Okay, so that was number 20. How about 25? How about 25? Is this u substitution or is this something else? Do you think u substitution will work for this? How do we know? Let's remember what u is supposed to be. Yeah, our choice of u is the inside function. So in that case, it would be 11 plus x to the 6th. And if you made the right choice for u, then the derivative of u should give you the other piece that you needed in your original integral. So yes, u substitution will work. Because by making the inside function be our u and then taking the derivative, it gave us another piece that was in our original integral. And that's what you want to do. You want to account for everything. You want to choose a u substitution that will account for everything that you see in the original. So we bring the 6 over. That means 1/60 u is equal to x. Oops, I forgot to put dx. There. So yeah, now we can replace everything. And how do I rewrite my square root? The square root is defined as power to the 1/2. So this becomes the integral of 1/6 u to the 1/2 u. Because I replace x to the 5th with 1/6, I replace dx with du, I replace 11 plus x to the 6th with u, and I replace the square root with to the 1/2. And again, you can bring the 1/6 outside the integral, so you're just doing the integral of x of u to the 1/2, which is just a straightforward anti-power rule. So the anti-power rule, you add 1. So in other words, you add 2 over 2. Because of u to the 3/2 divide by, hey, what's 1 divided by 3/2? That one you can do in your head. Just write down the answer. 1 divided by 3/2 is? It's just 2/3. You just write down the reciprocal. And that's being multiplied by the 1/6 that was out front. And we have a plus c, so this is all what? 2 goes into 6 3 times, that's 1/9 u to the 3 halves plus c, is that correct so far? Did you all get that answer? Okay. And the last thing we do is plug back in for u. So 1/9 11 plus x to the 6th. Is that it? And that's it. Other thoughts about number 25? Oh, that's what I was going to say. You can always show scratch work. 1 divided by 3 halves. That's 1 divided by 3 halves. That's 1 times 2/3, which is 2/3. So always feel free to do that fraction work, just scratch work on your page. Okay, 27. Ooh. What should we do here? First of all, is that a formula we have? Is that a simple integral? And maybe I can go ahead now and write out what our simple integrals are. So the simple integrals we know are the anti-power rule. We have e to the, oops. We have 1 over x. We have the natural log of x. Were there any other simple ones we had? I think those were all the simple ones. And then we had u substitution. And then we had integration by parts. So is this a simple one? Is it one of our first 4? What does it look like? Yeah, out of the first 4, which one does that one look like? The first one?
You don't have the e to the x.
Oh, I just wrote this one down. If e to the x, if n is 1, then it would just be e to the x. Yeah. Which one does it look like? And first of all, that dx, they put that dx on top. It should really just be 1. Yeah, 1 over 4x plus 6.
So 1x.
Yeah, so it looks like 1 over x. It looks like 1 over x. It's not just 1 over x. It's 1 over 4x plus 6. So what could we do to deal with the fact that it's 4x plus 6? Because it has to look exactly like that in order to use the rule. We can't just take the derivative of what's in there. It's the same technique we just did for the last 2 problems. Yeah, we'll just do u substitution. So if we let u equal 4x plus 6, because technically 4x plus 6 is an inside function. It's inside the denominator of an overall fraction. So if we do that, then du would be 4 dx, and you move the 4 over. That gives us a substitution. So now we're just looking at the integral from 0 to 1 of 1 over u du with a 1/4. It's also a 1/4. Okay, so did that work? Now it's a simple integral. Now it's going to be 1/4 times the integral of 0 to 1 of 1 over u du. So the integral of 1 over u is Yeah, natural log of u evaluated from 0 to 1, all with the 1/4 out front. And so we're going to evaluate. Fundamental theorem of calculus says parenthesis minus parenthesis, so that's natural log of 1 minus natural log of 0. Oh, no, it's not. There's something we have to do first. Before you can evaluate, what do we have to do?
The u back.
Yeah, put the u back in. So this is really natural log of 4x plus 6, which is being evaluated from 0 to 1. Yeah, sorry, we're plugging 0 and 1 into the original, not into u. So there we have it. Now that's going to be the fundamental theorem of calculus is something minus something. So that's natural log of 4 times 1 plus 6 is natural log of 10. Minus the natural log of 4 times 0, 0 plus 6 is 6. So we really have 1/4 times natural log of 10 minus the natural log of 6. Boy, that's sloppy. I'm sorry. 1/4 times the natural log of 10 minus the natural log of 6. There, that looks better. Now what do we do with all that?
Solving.
You just plug it into your calculator. If you really wanted to, there is a logarithm rule that states that a log minus a log is the log of the quotient. So you could say 1/4 natural log of 10/6. But really, we're just trying to get a decimal. Not that, yes, you have to type in the exact. But on the test, I would like you just to get a decimal. So you would do log 10 minus log 6 times 1/4. And what did you all get? Oh, good, I did too. 0.1277. So a lot of u substitution on the test. How are you going to know when to do u substitution? No, that's the question. How are you going to know when to use u substitution? Because it's not a simple integral, right? If it's a simple integral, you can just use one of these rules. But if it's not, then you want to try u substitution. So what was that, 27? Did anyone ask? Oh, we did ask for number 28. Okay, great. Number 28. What rule applies for number 28? And for instance, folks, when you're taking the test, every time I would just sit there and look down the list and say, okay, what does that look like? This is an integral of 400. Does the 400 matter? You just bring that outside. So it's e to the 0.11x. What rule applies to e to the 0.11x? Yeah, just e to the nx. So this is just a simple integral. This is not a u substitution or anything. You'll just have your integral of 400 e to the 0.11x dx. And so you can bring the 400 outside. So that's the integral of e to the 0.11x dx. And so that's, how do you do the integral of e to the nx? 1 over 0.11 e to the 0.1x. That's it. Well, of course, we want to deal with this. Let's go ahead and multiply that together, the 400 times the fraction, to get something a little cleaner. So that's 400 divided by 0.11. That gives us 36 repeating, e to the 0.11x. Plus c. Yeah, anytime it's an indefinite integral, you would just write plus c. 29 works the same way. Hey, that's funny. Nobody asked for 29. Did no one ask for 29 because it's just like 28? And 28 looks harder? So you figured if you can do 28, you can do 29? You guys noticed that within a minute, 2 people just left the room. First Wendy and then Daniel. I was just wondering, have you guys ever thought about punking your teachers? Like, don't do it to me because this was my idea. But like, what if on a particular day you all agreed before class? You're like, all right, starting at 12:25, we're all gonna walk out, 1 person at a time every minute. So like, boom, Wendy walks out. Boom, Daniel walks out. Then Lewis walks out. Then Elias walks out. Then Anna walks out. And then Ashley, and then Mario, and then Karina. And then finally, there's just 1 person left. And I'm like looking at them, like confused. And then they just get up and leave. Folks, this would be hilarious if you punked your teachers like this. Would any of you have the guts to do it? Obviously, don't do it to me, but go do it to one of your other teachers. It's hilarious. Just a thought, just a thought. Okay, questions about, yeah, Anna.
Could we, this one right here, can we leave it as a fraction?
Yes, you can leave it as a fraction.
That's correct.
Of course it would still be correct. So if you wrote your final answer as 40,000 11ths e to the 0.11x, is that what you're asking?
Yeah.
Or did you want to leave it as 400 over 0.11?
400.
If you do 400 over 0.11 in your calculator and hit math it'll give you this. Better yet, Anna, if you do 400 over 0.11, you can move that decimal twice and move that decimal twice. And if you move them both twice, you get the answer with 2 extra zeros. Then you get that answer. Is that what you're asking?
Yes.
It's just kind of a standard thing that if you're going to write a fraction, don't put a decimal in the bottom. Move the decimal however many times you have to so that it's whole numbers.
So then you put that in there.
Yeah. All right. Number 34. Ah, good. So this is a volume of a solid obtained by rotating about the x-axis. Who remembers that formula? The volume of revolution formula. It's the integral of let's write this all down together. To do a solid, remember we're essentially finding the volume of a cylinder. We're essentially finding the volume of a cylinder. And the volume of a cylinder is the area of the base times the overall height of that cylinder. So if I turn that sideways and look at this picture of what we're about to do, we're about to do a volume of revolution of x to the 1/3. I imagine that that looks a little bit like this. There's our function, and it's going from 0 to 5. So there's 0, there's 5. And so we would have something that looks like this. And we'd like to find the volume of that whole 3-dimensional object. So we're essentially turning my cylinder sideways, and we're looking at a cylinder that narrows down to a point. But the basic area of a cylinder is still area of the base, which is the cross section, times the height, which is really the thickness. So we're looking at the area of a cross section times the thickness. So that's the first I'm going to write down. Area of cross section times the thickness. I hope when you look at that, you recognize that as the formula for the volume of a cylinder. Because the volume of a cylinder is the area of the base times the thickness, which is the height. So then what are we looking at? A cross section, what's the shape of every cross section going to be? Just a circle. And so the area of a cross section of a circle is just pi r squared. And the thickness, remember we're looking for something that's infinitely thin. So you could either put a delta x there, or instead of a delta x, we could just put dx. And that dx is actually what is at the end of every integral problem, is the thickness of a slice. So I suppose I could put dx instead of delta x, right? All right, so then what is the radius? The radius of our circle is actually just the radius of that circle is the height of the function. Just like Karina clarified a second ago, that if you want to know the y-coordinate or the height, that's just the function itself. So in this case, the radius is really the function. And what's our function? X to the 1/3. So it's really pi x to the 1/3 squared dx. And that's the integral we're looking for, from 0 to 5. Now, I don't know if you like seeing all this, like the conceptual reminder of what we're doing. We're doing the area of the cross-section, which is always a circle, times the thickness, which is always dx. So instead of writing that all out in words, if you wanted to, it could be the volume of revolution is always going to be pi r squared dx, where the radius is always the function squared dx. So in this particular case, we're doing pi, the function, squared dx. And so how do you do x to the 1/3 squared? What's x to the 1/3 to the 2? What do you do with those exponents when you raise an exponent to an exponent? Do you add them, subtract them, multiply them? Yeah, you multiply them. That's our exponent rule. So now that's x to the 2/3. Yes. Okay, so there's a lot of thinking that goes on just to get you to the actual formula that you're actually integrating. The formula we're integrating is this. And so what can we do with the pi? For convenience sake, we can just bring the pi out front. So we're just dealing with x to the 2/3. Do we have to do u substitution? Do we have to do u substitution? No, this is just a simple integral. It's a simple one. It's just x to some power. So we do the anti-power rule, add 1, or in this case, 3/3. So we add 3/3, that gives us x to the 5/3. And again, everybody off the top of your head, 1 divided by 5/3 is 3/5. So that's the anti-power rule. There's still a pi out front. And we're going to evaluate that from 0 to 5. Now, in this case, is that 0 convenient? Yeah, very convenient, because when you plug 0 in, the whole thing becomes 0. So we're really just saying the answer is pi 3/5 times 5 to the 5/3. Now, you can clean that up in various ways. You could call that 3 pi fifths times 5 to the 5/3. Or you could even put that 5 in the numerator, and the answer would be 3 pi times 5 to the 5/3 all over 5. Or, since there's a 5 on top and bottom, actually, how do you simplify that 5 down there? This is another exponent rule. On the bottom, we have 5. That's really 5 to the power of 1, which is really 5 to the 3/3. How do you deal with these two 5s right here? When you divide two numbers that have the same base, yeah, you subtract the exponents. So now this is really 3 times pi times 5 to the 2/3. And now we're done. Of course, we should probably get a decimal. Because I think the answer key gives a decimal, doesn't it? So that would be 3 times pi times 5 to the 2/3. Did anyone get, or more importantly, did the back get 27.56? It is, Daniel? That's what you got?
So all three of those last, those are just three different ways.
Yeah, there's just 3 different ways of writing the same thing.
I put it in wrong, but yeah.
Yeah. I mean, you could just stop here if you'd like.
I put it that way.
But I was trying to simplify it. This would definitely be the simplified. You got it down to as few characters as possible. But yeah, all four of those last things are all just manipulation. Oh my gosh, it's been a while since we've said this. What is calculus? Lots and lots of algebra with lots of cancellation and simplifying. So much of calculus is just simplifying your results to look nice. Because where did we actually do the integral? Right here, right? So that's where we did calculus. Everything else before that was just understanding the problem, and everything else after that was just algebraic manipulation. So the actual calculus was just one step out of very many. All right, was the answer 27.56? Oh, good. Okay, well, folks, those were the most desired questions. So how about let's go back through to any others that had some votes on them. So I think now I'll look at the ones that had 3 votes. So that leaves us with 20 and 39.
Oh, that's the same.
So let's go ahead and look at 39 right now. Ah, good. So 39, this is also a format. Suppose you deposit $7,000 at 4% interest compounded continuously. Find the average value. Well, let's start with the problem statement. Suppose you deposit $7,000 compounded continuously, so your money is increasing like that, and you're looking over the first 3 years, so there's year 1, year 2, year 3, and it's earning interest compounded continuously. What's the formula for that? Remember, this is not the formula. You have compounded interest, which is 1 plus r over n to the nt. But what about when your interest is compounded continuously? Yeah, PERT, b e to the rt. So this is continuous, not just 2 times a year, or 4 times a year, or 12 times a year, but infinitely many times per year. So that's technically what we're doing. We just invested some money at 4% compounded continuously, so the amount of money in our bank account is going up. And they're saying, if you take a look at this graph, in the beginning I have $7,000. How much do I have at the end? How do we find out? How much money do we have at the end? What was our interest rate? 104 times how many years? 3. Everybody go ahead and plug that into your calculator and find out how much money you have at the end of the 3 years. Did anyone get 7892? Okay. Every once in a while, folks, we all know that investing money is good. You all know that earning interest is good. That you want to start saving money while you're young, like you. And that way, by the time you're 60 or 70 years old, you'll have earned lots and lots of money in interest, and you'll have lots of money to retire on. So we all know investing is good. But looking at that, are you very excited that after 3 years, you earned $892? It's a little demotivating when you look at it like this. You're like, geez, 892, that's 900 basically. So that's like 300 a year. $300 a year, how much is that per day, roughly? $300 in 365 days? It's like $1 a day, a little less than $1 a day. Again, I could go out on the street and find $1. But the point is not what you can do in 3 years. The point is what you can do in 30 years.
30 years?
Yeah, I mean, most of us are going to work for at least 30 years, right? If you look at your working career, you start working maybe when you're 20, and then you're going to work until at least you're 50. Chances are you're going to work until you're 60 or 70. So you don't, what?
23,000.
How much?
23,000.
23,000, now we're talking. So you're saying that's how many years? 30 years?
30 years.
Okay, yeah, I mean, 30 years. See, we can all part with $7,000. Like if you suddenly got $7,000, just don't touch it, put it in the bank. You didn't need it.
Just don't rely on that for retirement.
What?
Just don't rely on that for your retirement.
Yeah, not 7,000. But if you're waiting, that was 30 years, you said? Yeah, so 30 years. Well, now that's great. You just made 14. No, sorry, you just made how much?
16.
The $16,000. Now, Daniel, what if it was 40 years? Since you already have your calculator primed up.
34,631.
Oh, bama. Yeah. See, now we're talking.
Last year.
And what?
Only last year.
Well, that's true. But what if you're investing $7,000 every year?
That's it.
Yeah, like if every year you're investing, if every single year you save $7,000 and put it into an interest-bearing account, by the time you retire, you're going to be in good shape. Yeah, and really, folks, when you think about bare minimum, what can you all do? I'm sorry, I'm like on a soapbox right now. I'm trying to help you all retire and save money. But how much money could you save every month? Really, truly, how much could you save every month? What?
100 maybe.
Yeah, I mean at least $100. Everybody can save $100 a month. Everybody. And if you do that, then now you have $1,200 a year. And you could probably bump that up. You could probably do more than that per year.
Yeah.
So now you start putting that in for the next 40 years. Well, first of all, how much money is that? This times 40. That's already $48,000. But then that $48,000, you're investing it at hopefully 2% interest. So in 40 years from now, how much money are you going to have? I mean, this is going to be at least, maybe $200,000. And who doesn't want to go into retirement with at least a couple $100,000?
For how many years?
Let's just say 30. But keep in mind that's if you had the 48,000 to invest today.
Oh,
But what was it?
87,260.
Wait.
2% interest?
Yeah, 2% interest. Yeah. Okay, so it doubled. Well, hey, that's not terrible. And that's just the bare minimum of saving, that. Okay. Okay, so we didn't even finish this problem yet, did we? Okay, so let's go back to business. So, how much money do we have at the end? 7,800. 7,892.48. Now they're asking, what's the average amount of money? So the average amount of money, you'd want to draw a dashed line that represents to you the average amount. That would mean that the area above the dotted line is equal to the missing area below the dotted line. So does it appear that I drew that dotted line appropriately? That this amount of area, if I melted it down and poured it in here, would fill that amount of area? I mean, what do you think? Do I have to move the dotted line down or up? Or does it look good? It's supposed to be a wash. So that's what we're asking for. Right here, this is the average amount of money. And the formula for average money, or the average amount of money, is 1 over b minus a, the integral from a to b of whatever the function is. In this case, it's p e to the rt. So to get the average, you just do 1 over b minus a times the normal integral that you would do. So in this case, we've got 1 over 3 minus 0, integral from 0 to 3 of 7,000 e to the 0.04 t dt. Of course, 1 over 3 minus 0. I'm not going to take off points if you don't write 1 over 3 minus 0. If you just write 1/3, that's okay too. Oh, well, yeah. So what do we do next? That's the integral that we're actually trying to solve to tell us the average amount of money in the bank. What do we do next? You might always be asking yourself, which integral formula am I going to use? Yeah, just the regular e to the nx. But what can we do first? Yeah, move that 7,000 outside just to get it out of the way. So now we really have 7,000 thirds, integral from 0 to 3 of e to the 0.04 t dt. And so that's the 7,000 thirds times bracket 1 over 0.04 e to the 0.04 t evaluated from 0 to 3. Is that correct? What should we do next to clean up? You know, before plugging in the upper and lower limit of integration and subtracting for the fundamental theorem of calculus, what can we do to just clean that up? What could we do? We've got a whole lot of constants out here. We could just go ahead and evaluate all those. Just go ahead and do 7,000 divided by 3 times, or divided by 0.04. So instead of having all those numbers, we can get one number. So 7,000 divided by 3 divided by 0.04. And that gives us 58,333.3 repeating times this thing. And so the fundamental theorem of calculus tells us that you subtract parenthesis minus parenthesis. So that's e to the 0.12 minus e to the 0. Is this working? I would probably keep as many decimals as possible. Did anyone else get 7437? 32 as the average value. And is that a reasonable value? Does 7437 make sense? It looks like it. I mean, at the very least, it's between 7,000 and 7892, and it's about halfway between. So yeah, that looks like a reasonable value for the average amount. And again, what we're saying is that the total amount of area under the curvy curve is equal to the total amount of area under the dashed line. That those two amount of areas are equal to each other. So what was that, 39? Questions about that one? Well, I think we have time for one more. It's the last one that had 3 votes, which is number 20. I tell you what. Wait. Maybe I did put that on the test. I was about to say, it's not on the test. It's not on the test. You can all just scratch it out. Oh, it's on the test. Let's do that one. So how do we do this integral? I'll do it right there. From 4 to 5. Now, this integral is really fun because is it one of our simple integral formulas? It's not a simple integral formula, so that makes you think that you might have to do what? U substitution. But the fact is, this one, U substitution doesn't apply and won't work, and what we really have to do is just simplify. So anytime you have a sum in the numerator, you can break that apart into two separate fractions being added together. So let's do that first. We can break this apart into 8x squared over, now root x is really x to the 1/2, right? Over x to the 1/2. So that's our first step. It's a complex integral, but you don't actually have to do u substitution. And in fact, u substitution won't work. What you really have to do is simplify the expression. And now how do I rewrite this? What happens when you divide two numbers? What do you do with the exponents? It's not multiply, what? It's not reciprocal. You subtract the exponents. Yeah. When you divide the x to the 2, divide by x to the 1/2, you subtract. So this is really 8x to the 3/2. Is that correct? 2 minus 1/2. 2 minus 1/2 is 3/2. And then this one, there's no x on top to subtract with, but how do you get that x back up into the numerator? Make it a negative, so now that's plus 9x to the negative 1/2. So there we go. Just by algebraic manipulation, we've converted that into a simple integral, where now that's just the anti-power rule, and that's just the anti-power rule. So we can add 1 and divide by the result. So I'm going to add 2 halves. That's x to the 5 halves. So now that's 8 divided by 5 halves. And then this, add 1 or add 2 halves. So that's x to the 1/2. And then 9 divided by the 1/2. So there's just the technical application of the anti-power rule. I added 1 to the exponent and divided by the resulting exponent. I added 1 to the exponent and divided by the resulting exponent. So now you have to do a little fraction work. And
Oh, sorry, I'm just a little confused in one of the parts.
what's part?
Can you just go up back again when you divide on the top one? Yeah, when you divide it again down, please. You have to get that 3 over 2.
Okay, so x to the 2 divided by x to the 1/2. You're going to subtract the exponents, so that's x to the 2 minus 1/2. And what's 2 minus 1/2? I can rewrite 2 as 4 halves. Right? Isn't 2 4 halves?
Mm-hmm.
So 4 halves minus 1/2? 3 halves. Yeah, thanks. Okay, so now we clean all that up. So 8 divided by 5 halves would be 8 times 2/5, which is, so 16/5 x to the 5 halves plus 18 x to the 1/2. And we're going to evaluate that all from 4 to 5. And what's the appropriate way to do all that? On your calculator. So plug 5 into all that, plug 4 into all that, and then subtract. Daniel.
Yeah, no mind. I just didn't see the negative. When you turned the negative to positive, you added.
Yes. I added 2 halves to that. Okay. Okay. Like I said, that one, it finishes by putting it all into your calculator. So let's see. I don't have anything to pass back to you. I think everybody has everything they need. All of the solutions to all of these problems are online in the announcements. So you can download them and look. Keep in mind, you can all feel free to email me anytime you like, either through the mat213 program or just email me. And I'd be happy to email you back with any solutions. You can also come to my office hours, which is right now. As soon as class ends, I'm just going to walk over to my office. And otherwise, your test is on Tuesday.
So our test is Tuesday, and then we have final, we study for final Thursday and final Tuesday after.
Yes, so that means for next week, I can email it to you, but I'll give you a practice final next week. Yeah, I'll give you a practice final exam. Yeah, so Tuesday you'll take the test, I'll give you the practice final exam. Thursday we'll do the practice final exam, and then the next week you get to take your final.
Now, is our final on everything in this whole semester, or?
It's everything from this semester and your entire life going back to 3rd grade.
Perfect, I'm ready.
Yeah.
I have to wait my life for this moment.
Yeah, everything from your whole life until this very moment. Thank you, Daniel. That's very funny. I like that.